Hello, my mathematicians. Today we are looking at Module 5, Lesson 4. It's about finding the volume of right rectangular prisms. Hopefully by the end of this lesson, you'll be able to find the volume of a right rectangular prism using the area of the base and the height. We're going to start with the spark you're learning. It says, for his junior engineering club, Miguel is designing a box in the shape of a right rectangular prism that can hold exactly 12 1-inch number cubes with no extra space. What are the dimensions in the volume of a box Miguel can design? Justify your reasoning. Well, if we look, so for his junior, it says they can hold exactly 12 1-inch number cubes with no extra space. Okay, so that means that the volume is going to be, if each one has a volume of 1 inch, then and there's 12 of them, your volume is going to equal 12 inches cubed. Okay, so if we want to figure out the dimensions, there's a couple different things we can have. We can kind of look at this picture here and think, well, if we just stacked them, we're going over 4. So that would be 4 inches by, it's going back 1 inch, and the height would be 3 inches. So that would be a possibility. We have other ways that we can get 12. So we can split up the 4. So we could have 2 inches by 2 inches by the 3 inches. We could have 6 inches by 2 inches by 1 inch, and there are others. Make this look more like a 1. Okay, so basically they all have to be filled in with gaps, so always do that. All of these show 12 number cubes and have a volume of 12 cubic inches. So then we can go to the next page. So it says Naomi works at a health food company. She needs to stack 1-inch protein cubes in a box, as shown, with no extra space. So it says, what is the area of the base of the box? So the base would be this right here. So if we look over, we have 1, 2, 3, 4, and we have 2. So it's 4 by 2. So we're going to do 4 times 2. So it's going to be equal 8 square inches, or inches squared. And it says, what is the volume for one layer of the cubes? Explain how you know. Well, it's only going up 1. So the volume would be 8 inches cubed, because each cube has a volume of 1 cubic inch. And there are 8 cubes. So then it says, how is the volume of the prism different from the area of the base it is sitting on. Well, if we look at the units here, we have volume has inches cubed, and area has inches squared. So the difference is the units. So the volume is measured in inches in cubic units. And the area is measured in square units. So that's the difference between area and volume and how we label it. We have inches squared for the area because we're doing length times width, so we have 2 dimensions. And we have inches cubed for volume because we're doing 3 dimensions, length times width times height. So it says, as each layer is added on top of the base layer, how does the volume change? Well, the volume would increase by 8 because each layer is 8 cubic inches. So the volume increases by 8 cubic inches or inches cubed. So if we fill in this table, 1 layer, there's 8. 2 layers, there's 16. Then 24, 32, 40. So how is the volume related to the height? Well, the volume is 8 times as great as the height. So what is the volume of Naomi's box? Well, there are 1, 2, 3, 4, 5 layers. So we said 5 times 8 was 40. So it would be 40 inches cubed. So then if we go to the next page, it says Angela is a culinary artist. She wants to pack the 1 centimeter food cubes into a container as shown. What is the volume of the 1 food cube and how do you know? Well, it's just asking about one of the cubes here, the volume of 1 food cube. It says that they're a centimeter, so that means it'd be 1 centimeter cubed because a centimeter cube is a unit cube. So has a volume of 1 centimeter cubed. Then it says, how many 1 centimeter food cubes will she pack into the container? How can you use this amount to find the volume of the container? Well, if we look, she has 1, 2, 3, 4, 5, 6 across. 1, 2, 3, 4, 5 back. So we're going to start with 6 times 5, which equals 30. And then 1, 2, 3, 4, 5, 6, 7. So 7 times 3 is 21. Then we add the 0. So we get 210 food cubes. And then we would multiply that by the volume. So multiply the number of cubes by the volume of each cube. So it says, what is the area of the base of the container that Angela needs? Well, we already said these are each a centimeter, so we said 6 times 5 is 30. So 30 centimeters squared. And the height we said was 7, so 7 centimeters. So this is write a numerical expression using the height to model the volume of the container. Well, we already kind of did this up top, but we would do 7 times 30. And we get 210 centimeters cubed. And it is the same as our answer from part B. So now we are going to look at the last page of this lesson. So it says, Angela rearranges her 1 centimeter food cubes as shown. What are the length and width of the base? Well, we count across. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 centimeters. And the width would be 1, 2, 3, 4, 5 centimeters. So our numerical expression to find the area of the base would be 7 times 5. And then the height, 1, 2, 3, 4, 5, 6. So that'd be 6. And numerical expression to find the volume would just be that whole 7 times 5. And then we multiply it by 6. So then it says use your expression to find the volume. And how does your answer compare to the volume found in the step it out 2? Well, so we start 7 times 5 equals 35. And we do times 6. We need to write it out. We can. 35 times 6, 30, 18, 19, 20, 21. So equals 210. So we get 210 centimeters cubed. And it is the same. So this is our lesson. I hope that it helps you understand a little bit better and that you now can find the volume of a rectangular prism using the area of the base and the height. Remember, in order to be a math person, all you have to do is be a person and do math.